Good evening, everyone. I am Mrs.S.Savitha. I am working as Assistant Professor in Department of CSE, KSR College of Engineering, Tirchangur. So today my lecture topic is software testing strategies. In today's topic, we are going to look on what are the testing strategies available and how they are applied for conventional software and object-oriented software and validation testing, system testing. So first of all, what is software testing? So software testing is a process of exercising a program with the intention to find the error prior to the delivery of the software to the user or the customer. So why should we find the error? In the sense, in order to ensure the quality of the software, we have to find the errors. Then the strategy for testing conventional software. So here the loop contains 4 layers. The very inner loop contains the coding. So coding has been tested with the help of unit testing method. Then design. So design is nothing but a kind of architectural design. So in design we have to connect each and every component with others. So design will be tested by integration testing tool. Then out of that requirements are gathered by the business analyst. So whatever the requirements gathered that has been accomplished or not, that will be tested in validation testing. Then system engineering is tested as a whole. So whatever the system we are delivering to the customer, that will be tested in system testing. So in lifecycle model, initially we begin with requirements collection. Then initially we begin with planning, then we will collect the requirements, then we go for design, then coding, then testing, then deployment, right? The same thing happens here also. So system engineering is connected with system testing, requirements engineering is connected with validation testing, design is connected with integration testing, and code is connected with unit testing. Next, what are the levels of testing? So whatever we have seen in the last slide that has been shown here. Unit testing. So unit testing concentrates on each and every component of the software. So whatever the source code we have used, those source codes will be tested uniquely, and then it will be check on to the next level. So either all the codes are working functionally well or not. Then integration testing. After we constructing units, each and every units, that will be combined to form a single system, right? So here we have to integrate each and every units to a single component. So design and construction of the software is focused on integration testing. After combining each and every units with others, either the system is functioning well or not, that will be tested in integration testing. Then validation testing. After the complete integration is over, we got the full layout of the system. Now we have to check whether the system is working for whatever the purpose it has been developed. That is called as validation testing. So whatever the input we are giving, for that whatever the output that is giving, so is it satisfied by the customer, that is validated in validation testing. Then system testing. All the components of the system will be tested in system testing. So the same thing explained further here. So we are validating in unit testing, we are validating separate units of the source code. Say for example, whatever the functions we are used, whatever the data variables we have used, like that, and what are the conditions used in loop, everything will be tested. In integration, what are all the components fit together and work together, that will be tested. So one unit will be worked with another unit. So either they may, whatever the dependent units will be tested in integration testing. Then on validation testing meets the behavioral and performance and functional performance requirements of the software, or everything will be tested in validation testing. In system testing will be all the stakeholders of the system, like people, users, customers, everyone. So either the system is fulfilling all the requirements of all the stakeholders. So both hardware and software and people and database, everything has been achieved well or not. That will be tested in system testing. Now testing for conventional software. So in unit testing for conventional software, we are in need of two things. One is cohesion and another one is coupling. Cohesion means independency between modules. So cohesion, one module, when we encounter an error in one module, and if we are correcting that error, surely it will give some more errors. So in such a way that the correction in the particular module should not affect the code or performance of another module. So this is called as independency among modules. In specific term, we can call it as cohesion. So independency between modules will be called as cohesion. So cohesion, what is the need of cohesion? In the sense, it reduces the number of test cases. So when we having independency between modules, surely the number of test cases will be decreased, and whatever the errors are predicted, easily we can uncover them without affecting another module. So that will be achieved with the help of cohesion. And cyclomatic complexity, it mainly focuses on critical modules. So the modules which are all highly important to the system or software, that those are all tested here. So that is called as cyclomatic complexity. We should have reduced cyclomatic complexity. So in unit testing, this is the diagrammatic representation of unit testing. Here interface is used. All the interfaces will be tested, all the local data structures will be tested, all the boundary conditions will be tested, and independent paths and error handling paths, everything will be tested under unit testing. So whatever we have told in the previous diagram, that has been explained here. Then unit test environment. Here unit test environment, we are testing individual components, either it may be a smaller components or bigger components. So for smaller components, it can be called as stub. So each and every stub can be tested, sometimes with the help of driver software. So we have to develop some modules may be in need of upper level supporting system, that is called as driver, and some module may be in need of stubs, that are lower level components to the module. So when we are individually checking a unit, we may need driver software or stub software to test that particular module. So that is a part of supporting method. Here driver module is a main program that accepts the test case data, and stubs replace the modules that are subordinate to the actual module we are using. So drivers and stubs both are represents a overhead to the module. Then integration testing. It is a systematic technique for constructing the software architecture. So here we are integrating individual units to bring a single whole software. So whenever the integration is occurring, we need to conduct individual tests to uncover the errors. Say for example, if we are having 5 number of units, we cannot attach all the 5 number of units at a time. But if we attach or if we integrate all the 5 units at a time, surely we may get lot of errors. In order to avoid that, we can combine unit by unit 1 and 2, then with unit 3, then with unit 4, like that we can integrate, so that we can easily uncover the errors and we can easily find out the errors where it has been occurred. So integration testing is having two types: non-incremental integration testing, incremental integration testing. So non-incremental integration testing is a big bang approach. First thing. Second one, incremental construction strategy. So let's see what is big bang approach. Non-incremental integration testing. So in big bang approach, all the components are combined in advance. That is, entire units, if we are having 10 number of units, all the 10 number of units will be combined and then they are tested as a whole. So here what is the problem occur in the sense we may not know where the error actually origins. The origin of the error cannot be identified accurately. That is the difficult here. So when we do not know the origin of the error, it is difficult to find or correct the error. So it seems to be endless loop. So in big bang approach, it is little bit tough to integrate all the units at the same time. But in incremental integration testing, we can do the integration level by level. That is top down integration or bottom up integration. So that is, we are combining the units in small level and we are testing, and again we will combine the unit in small level, we will test, so that we can grow gradually. So here interfaces are more likely to be tested completely. So whatever the interface unit 1, unit 2 will be integrated with one interface 1. So that will be tested, and unit 1, 2 along with unit 3, it may have some other interface that will be tested separately. So everything will be tested separately. So first thing, top down approach. Here top module is tested with stubs. Stub means it's a subordinate program, driver means it's a main program supporting. So both drivers and stubs are supporting the modules. So here stubs are replaced one at a time, so in depth first manner. So say for example, in top down integration, we are taking first module 1 M1 at the first time, and then we are integrating it with M2 and we are testing it. Once all the errors are clear, then we will integrate it with M3. Now again we test for errors. If M1, M2, M3 is not giving any error, then we go for M4. Now M4 is integrated with M1, M2, M3 and M4. Again we test it. If there are no errors, then we go for M5 to be integrated. And once M5 is integrated and all the errors have been cleared, then we go for M6. So here M6, another M6 is a stub module. That is for supporting purpose they have used. So in top down integration, we can go in two kinds of way: depth first search or breadth first search. So in depth first manner, we can integrate all the components. Otherwise in breadth first manner, we can integrate all the components. So here we are integrating all the components in depth first manner. So here we are verifying major components. Then bottom up integration. In bottom up integration, we are coming from lower level to upper level. So in cluster 1, we are having some components. So that will be tested along with driver software, and if it is clear, then it will be integrated with MA. If it is clear, again cluster 2 will be tested again, and it will be tested with driver software. If it is clear, if there is no error, then it will be again clubbed with MA. So once all the cluster 1, cluster 2 and MA have been tested and combined together, then we combine it with MC, integrated it with MC. Then it will be integrated with MB. So bottom up approach starts from bottom to the top. So here we are using driver modules. So it starts with most atomic module, in the sense most lower level modules. From lowest level to the top level we are going. So this approach, it focuses on low level data processing early in the testing process, and we do not using stubs here. We are using only drivers because we are moving upwards in the sense upper level support only we need. So for upper level support we are in need of driver software. We don't need of stubs. So disadvantage, even driver module need to be built to test the lower level software. So driver module is always a high level module. Next, regression testing. So regression testing in the sense re-executing tests, small level tests. We are re-executing the small level tests, like that. If we are combining unit 1 and unit 2 and we have tested and we have corrected it, when we combine two things, if they give error, then we have combined it and again we will go for another testing. So first level testing is over, error is cleared. So again we are going to combine it with another module. Now again second level test will be happened. If any error will be occurred, then we go for again all the errors will be recorded and we give it to the development team. That development team will correct all the errors and give it back to the testing team. Now testing team again test the newly developed or newly updated unit. So this is called as regression testing. So we have to exercise all the software functions and we need to find the errors and we need to uncover the errors. So testing is, in regression testing, it is always done to verify the modified code does not break the existing functionality or any new work of the system that should not be affected because of new modification to the software. So that has been tested through regression testing. Now smoke testing. So smoke testing in the sense we are doing the testing daily. Whatever the daily builds done by the software production team, that will be tested. That is called as smoke testing. So whatever the software components that have been created or translated into code, that will be integrated as a build. So those builds are daily executed and tested for errors. So like data files, libraries, reusable modules, everything will be tested in smoke testing. The intent of smoke testing is to uncover showstopper errors. So whatever the errors that are highest likelihood, that will be shown by smoke testing. Next, benefits of smoke testing. So with the help of smoke testing, the integration risk is minimized because we are testing it daily, right? So integration risk is fully minimized and the quality of the end product is improved, much improved. Then error diagnosis and correction are simplified and the progress is easier to assess. Now we go for validation testing. Validation testing, whatever the outcome we are expecting is that achieved by the system, that is called as validation testing. So validation testing follows integration testing. After integration testing we go for validation testing, that is we are testing based on requirements of the customer, whether all the requirements of the customer have been achieved by the system or not. That is called as validation testing. So it is designed to ensure that all the functional requirements are satisfied or not, all the behavioral characteristics are achieved or not, all performance requirements are attained or not. These things are tested in validation testing. So here we are performing configuration review. All the elements of software are properly developed or catalogued or any other necessary details are missing or everything has been included, so that will be reviewed. So in validation testing, we are having two types, alpha testing and beta testing. Alpha testing is tested in developer side. So developer location, in developer location it will be tested by the end user, either by customer or by the end user it will be tested. So the software, while the end user is testing the software, the developer will accompany him so that he will easily test the software, and also the software is in controlled environment, because whatever the development environment, there the software is tested, right, in alpha testing. So the software is tested in controlled environment, but in beta testing the software is installed and tested in end user's location. So wherever the software is going to be delivered, there it will be deployed and it will be tested. So here generally developer may not present, only the user will test the software. So it serves as a application software in an environment that cannot be controlled by the developer, because in developer environment may drastically vary from user environment. So in a new environment the software is going to work. So that is what tested in beta testing. So once the beta testing is completed, the software engineers will come to know that okay, the software is ready for delivery, so that we can release the product to the market. Then finally system testing. So system testing in the sense system as a whole in the sense in case of failure, in case of any problem, how the system will recover, that will be tested in system testing. So in system testing, different types: recovery testing, security testing and stress testing. So recovery testing tests for recovery from system faults. If in case of sudden power shutdown, so what happens to the system, and what is MTTR in the sense mean time to repair, after the repair, how it has been retrieved from the repair, that is called as recovery testing. Then security testing, so it verifies the protection mechanism built in the system, so to secure the data from threats. Then stress testing, so abnormal resource handling or abnormal data handling, so these are all called as stress level. These things will test the stress level of the system. The system may get hanging, or in case of error input, how it is reacting, those things will be tested in stress testing. So these are all the testing strategies we are using here. Thanks for watching. Thank you.